Hello and welcome to our presentation. We will be presenting on the fluid dynamics of swim paddles. My name is Lillian Magnus and I am a junior mechanical engineering major.
Hello, I'm Alexander Estano, and I'm a junior mechanical engineering major here at Clarkson University.
My name is Bradley Bell. I am also a junior here at Clarkson, and I am a major in mechanical and aeronautical engineering.
My name is Sydney Canner, and I'm a junior majoring in mechanical engineering.
Our key question is what kind of paddle will provide swimmers with the best results in the water? The impact of this testing would be social, as it's affecting a large number of swimmers that currently use paddles in day-to-day practices. Swim paddles work the muscles in the back, arms, shoulders, and chest of individuals. All of these muscles are vital to be able to swim for prolonged periods of time. The results of this testing can help strengthen swimmers' muscles and provide faster results in the pool, which will lead to better times at competitions. On a simplistic view, we're going to be testing 5 individuals with 3 different paddles and 1 control, that being no paddles at all, and recording the results of these tests. From there, the data will be analyzed and ultimately 1 paddle will be deemed the best for training. It should be mentioned that most casual swimmers who use paddles can buy really any paddle out there in the market for training and will do just fine. The individuals who are looking for that extra edge, i.e. collegiate swimmers like ourselves, will find a use for this. In a sport where milliseconds determine first and second all the time, every little advantage one can get matters greatly. As aforementioned, the majority of the team members are swimmers here at Clarkson University, but all members are engineering students who look to optimize aerodynamics and performance. As athletes, we understand the importance of proper strength training and what methods are needed to get better in our sport. For our test, we'll be honing in on the wrist orientation while an individual swims. One must maximize how much water they are pulling in their stroke in order to achieve faster times. Determining which paddle is best at keeping the correct wrist orientation will not only improve swim performances, but also improve the odds of our school winning at competitions in the future. The key objective of this test is to determine which paddle design most closely resembles the wrist orientation of a swimmer that is not using a paddle in order to keep the training form consistent with technique. Our test did not originally start off like this, though. Our first idea was to create 3 of our own different paddle designs and attach them to the front of an RC boat and have it travel 25 meters. Based on which paddle that took the longest to get to the other side of the pool would mean that paddle had the most resistance and therefore was the best paddle design. This test plan, however, had its own multitude of issues. First off, the motion of a boat on the water is not the same motion of an arm of a swimmer. Secondly, since there's no practical way to keep the boat in a perfectly straight line, the boat could sway side to side because of the drag created by the paddle. We ultimately felt that there was just too many uncontrollable variables in the testing and could not simply ignore them. This led to our second idea. We would instead use already existing paddles of our fellow teammates and put them into the wind tunnel. From there, the paddle with the highest drag would be deemed the best because the higher amount of drag force would mean higher resistance for the swimmer. This test plan also led to its fair share of complications. First off, the Reynolds number for a swimmer would have to be converted to the same one in a wind tunnel. And then secondly, the viscosity would have to be changed since air and water are different fluids. We ultimately felt that since it was not the same medium fluid, we should avoid this idea and come up with something else. Now knowing what went wrong with our other 2 previous ideas, we had a better idea of what we wanted to do for a test plan. It came down to 3 final ideas. First was to create a pony brake, then look at the torque created when the object is released to simulate a swimmer, use a gyroscope to measure wrist orientation of a swimmer, or use a water turbine with different sizes and shapes of paddles to see which would create the most resistance. Ultimately, options 1 and 3 were avoided because we would have to make our own mechanical boxes, and that could lead to its own issues and problems. We also felt that we would be spending more time designing and building those mechanisms than actually being able to test the swim paddles, what we wanted to do.
The test plan, which was developed by this group, involved using an app which was found in an Apple Watch, which has both a gyroscope and an accelerometer, which allowed for the group to investigate both the wrist orientation and the acceleration of the swimmer using different paddles. The swimmer swam a distance of 25 meters using first no paddle, then 3 different paddles. Each test was run 3 times, so that means that the no paddles were used 3 times, etc., etc. From each trial, the data was then able to be averaged for each different swimmer, which allowed for the group to get a trend of which paddle provides about the same wrist orientation as using no paddles. It is important to have the same wrist orientation because it means that you are working the same muscles as you would when you are swimming without paddles, which would result in the best resistance training, which helps to build muscle and prevent injury. The equipment which was used was a Apple Watch SE second generation. This watch had an app downloaded on it called Sensor Log, which allowed for the group to gather data on both acceleration and the gyroscope, so the wrist orientation of the swimmer. This app interfaced with an iPhone 12 mini, which allowed for data to be gathered, which could then be transferred to a computer. The swimmers who tested each paddle and no paddle were Sydney Canner, Alex Astano, Lily Magnus, and Brad Bell. The data was gathered in the Clarkson Fuller pool. The top paddle, which was used, which is the all black one with the red straps, is the Speedo Nemesis Contour paddle. The middle one with the red and black with the red straps is the Speedo Power Plus paddles, and the bottom ones were the Stroke Maker paddles. The group used no paddle as a type of control. Since every swimmer is going to have a slightly different wrist orientation, we used not having a paddle as a control for each individual swimmer. It was then assumed that the wrist orientation for the Speedo Nemesis paddles would be the most similar to that of a normal swimmer without any paddles, since it has a very similar contour to that of an actual hand and has less holes and is a similar size to a person's hand. It was assumed that for the Speedo Power Plus, there would be a slightly different wrist orientation due to the fact that the paddle is much larger than your hand. There are many holes in it, and so the swimmer would most likely have to adjust their style to become comfortable swimming with them. For the Stroke Maker paddles, which are the yellow ones, it was assumed that the wrist orientation would show minor differences since it is slightly smaller than the Speedo Power Pluses. However, it is still flat and has holes, which would make it so that the swimmer would have to adjust their swimming style to the new paddle. The procedure is as follows. The group collected several different styles and shapes of swim paddles from different members of the Clarkson University swim and dive team. From there, a time was scheduled to use the pool when no other swimmers were present. This is because the disturbance in the water created by other swimmers could have thrown off data when testing. So it was determined that it would be best to use the pool when it was empty. From there, the Apple Watch was set up so that it could be attached to the hand of the swimmer. So for each paddle, it was placed on the front side of the paddle. And then when there was no paddle used, It was attached to these two fingers on the swimmer and then at their wrist. From there, the swimmers put on the paddle and got into the water, and the gyroscope app on the Apple Watch was activated. The swimmer then would swim 25 meters, and the app would be then stopped on the other end of the pool. This was repeated 3 times for each different paddle and when there was no paddle. And in addition to this, we had 4 different swimmers who collected data so that different styles of swimming could see if they had the same results for each different paddle. After this, we cleaned up the area and returned all paddles that were used to their owners. Then the data was uploaded to a computer and compared each trial run to each other to see which paddle most closely resembled wrist orientation of when there aren't paddles. These results were then tabulated and shown to the head coach of Clarkson's swim and dive team so that we could determine which paddle was optimal for training and if it was possible for each swimmer to get the same paddles. The total budget for this project was quite low due to the fact that all of the swim paddles were already owned by members of the Clarkson swim and dive team, so this group simply asked permission to borrow them for testing. In total, if you had to run the experiment without the equipment that was already provided, it would have been $60.59. However, since this group did not have to buy any of the swim paddles, it was only $5.99 to run the entire project. The overall risk of this project was quite low due to the fact that while we were doing experiments involving water and swimming, everyone who was involved in the testing were qualified swimmers who have been swimming for many, many years. There were 3 risks that were identified. The first was that the paddle could break and cut someone. It's a very low likelihood of this happening as all paddles were checked to be in good condition. It could pose a risk if this happened because it could cut the swimmer, which would create problems such as there's blood in the water, which is a health hazard, or the swimmer could be harmed. However, since it was such a low likelihood, the overall risk to the project was quite low. The next risk was that watchers could fall in the pool, which was a quite low likelihood because everyone in this group was familiar with being around a pool and knew to walk slowly and avoid patches of water that they could slip and fall into. So the severity of if this had happened wasn't that bad either, due to the fact that everyone in the group is qualified swimmers, so even if they fell in fully clothed, it wouldn't be that much of a problem. So once again, the overall risk was low. And then the last risk was that the swimmer could cut themselves on the lane line, which does happen, but due to the fact that we had the entire pool to ourselves, we were not swimming very close to lane lines. So if this had happened, it would have created a health hazard such as blood in the water again. But since it was such a low chance, the overall risk was low. So overall, this project did not have any risks that were that serious. Once a test plan was created and a risk assessment was conducted, we then conducted some preliminary testing, which consisted of strapping the Apple Watch to each of the paddles and to the hand of the swimmer to see if it would stay on to the paddle and swimmer when they were actually in motion. We had to refine the technique a bit. We first used tape, which immediately fell off when it got wet. And we eventually settled on using the rubber tubes, which are used to strap the paddles to the swimmer's hand in order to strap the watch to the paddles and the swimmer's hand. As can be seen in each picture, it had to be done a little bit differently for each paddle since there was a different orientation of extra holes on each paddle. So we had to get a little bit creative with how we did that at times. However, since we took these pictures, that made it easy to recreate it for each test. Next, we recorded data using the app and familiarized ourselves with the app. There were some initial issues with how we were recording the raw data, and it made it quite hard to actually get any information from. But after some fiddling around with the app, that was fixed, and we were able to do our actual testing, which was then conducted, and we were able to gather the data that we needed to make conclusions. This is a photo which was taken during testing and shows how each swimmer swam the front crawl for each test, which allowed for some consistency between each swimmer, although each swimmer will have a slightly different style, which is why we had a control and many tests for each paddle for each swimmer.
Before testing began, our group hypothesized that paddles with a larger surface area would have a more beneficial impact on swimmers during performance. This correlates to our yellow paddle we used in testing. Displayed in the graphs is our raw data collected from the Apple Watch directly after swimming. Pictured here is the logo for the SensorLog app, which we utilize during our testing. The app takes data, motion data used while swimming, and plots points over time. Shown here is raw data tabulated from the graphs shown earlier in the slides. This data includes 3 categories of acceleration, gyroscopic, and unbiased motion data. Now I'll go over our data analysis. For each swimmer, paddle, and category, we found the stroke percentage based on time, and for the first 12 strokes, averaged them for each category in order to get the data that we were able to tabulate. This section will show the average acceleration of all swim paddles compared to no swim paddles. Shown here is the control no paddle and the red paddle versus stroke percentage. Shown here is the control no paddle and the curved paddle versus stroke percentage. Finally, for acceleration, this is our control no paddle and the yellow paddle versus stroke percentage. Now begins the section of the average angle of rotation for every paddle with the control of no paddle versus stroke percentage. Displayed here is the control no paddle and the red paddle versus stroke percentage. This is the control of no paddle and the curved paddle versus stroke percentage. And finally, for angle of rotation, this is the control no paddle and the yellow paddle versus stroke percentage. This is the last section of results where, again, our control of no paddle is compared to of the 3 paddles for average rate of rotation. Shown here is the control of no paddle and the red paddle versus stroke percentage. Here our control no paddle and the curved paddle are shown versus stroke percentage. And finally, for rotation rate, the control no paddle and yellow paddle are shown versus stroke percentage. Now we'll go to the percentage error for all 3 categories. For the accelerometer, we found a percent error of plus or minus 1%. And for both the gyroscope and unbiased device motion data, we found a plus or minus 4% of error. This is highly encouraging and means that our data can be used.
When examining all of the plots, we looked at the z direction since that corresponds most with hand position. And when you look at the average acceleration, it can be seen that the red paddle has the greatest magnitude of acceleration throughout the 12 strokes. This is because the red paddle covers the most surface area. Then the curved paddle is the next highest magnitude, and then the yellow paddle. When looking at the average angle of rotation, the curved paddle stays the most consistent while the swimmer is swimming. And this is important since you don't want the wrist to be cocked and you don't want too much movement when the swimmer is swimming. And then looking at the average rate of rotation, the curved paddle had the highest rate of rotation when swimming. And this is important since the strokes are supposed to maintain a high rate of rotation. Based on the results, it can be seen that the curved paddle is the most optimal for training. The curved paddle had the most similar wrist orientation to using no paddle. This could have been hypothesized in the beginning since the paddle is almost the same size as all of the swimmer's hands, and it's also curved, which when a swimmer is swimming, their hands are usually cupped to grab more water. From here, the results could be shown to the Clarkson Swim and Dive coach, and they could decide to make all of the swimmers train using the same types of paddles, or further research could be done with more varieties of paddle designs to determine if there's one better than this one.